Hi everyone and welcome back to A in Economist. So in the previous lecture we have studied the fundamental concepts of set theory. Now in this particular lecture we will go into some of the numerical questions regarding the set theory and all we have studied in the previous lecture. This will make your concepts a little more clear. So let's get started. The first question says, write the following sets in the set builder form. Now in the set builder form, the elements of the set are written in terms of some logic, right? We have studied this in the previous lecture only. So what you need to do, you need to find the patterns in each of these elements so that you can form that logic. If you see this particular set, it has 4 elements, 3, 6, 9 and 12. So what you can write is something like this. Include all the x elements such that x is in the form 3n, where n belongs to the set of natural numbers, and 1 less than equals to n less than equals to 4. Why this is so? If you see, 3 can be written as 3 into 1, 6 can be written as 3 into 2, 9 can be written as 3 into 3 and 12 can be written as 3 into 4. Now if instead of 1, 2, 3, 4 you put n and set the range of n to be 1 to 4, where n belongs to set of natural numbers, you will get these 4 elements, right? I hope this is clear. Let's get into the second question. It has 2, 4, 8, 16, 32. So the first element is 2 to the power 1, second element is 2 square, third is 2 cube, this is 2 to the power 4 and this is 2 to the power 5. So write it in this fashion. X is 2 to the power n such that n belongs to n and 1 less than equals to n less than equals to 5. In the similar way we can do this question as well. X such that x is 5 to the power n, n belongs to natural numbers, and 1 less than equals to n less than equals to 4. This set is a little different because it has infinite number of elements, and if you see the elements you will notice that it is the set of even numbers, right? It is the set of even numbers. So you can write it x such that x is 2n, where n belongs to natural numbers and n, this has to be n, n can simply be written as greater than equals to 1, right? If you put 1 it will be 2, if you put 2 it will be 4, so on and so forth. So this set will have infinite elements. Then go to question number 5. It is 1, 4, 9, 10, 9 up to 100. So it will be x such that x equals to n square, where n belongs to natural numbers and 1 less than equals to n less than equals to 10. Right? I hope this is understood. So let's get to the second question. The second question says, in the following statement, state which of the following satisfies A equals to B criteria. So when will the set be equal? We have discussed it. When the elements in both the sets are equal. The ordering doesn't matter, but if the elements in both the sets are equal, they will be treated as equal sets. So let's see the first one. Set A has A, B, C, D. Set B has D, C, B, A. So the elements are the same. Irrespective of order, we will say that in the first case A equals to B, right? Let's see the second one. A has 4, 8, 12, 16 and B has 8, 4, 16 and 18. Now if you see, you will notice that 12 is an element which belongs to set A, but 12 does not belongs to set B. Again, 18 is an element which belongs to set B, but 18 does not belongs to set A, right? So we can say that A is not equals to B. Let us consider the third question. Set A has 2, 4, 6, 8, 10. Set B has x, where x is positive even integers, which is less than equals to 10. Now first write what will be in set B. Positive even integers. So what will that be? 2, 4, 6, 8, 10. Now this set exactly matches with set A, so these two sets are equal. Question number 4 says A is x, where x is a multiple of 10. So set A will be something like this: 10, 20, 30, 40, so on and so forth. And set B is given as this. Now if you see that 15 is an element which belongs to set B, but 15 does not belongs to set A. Similarly, 25 also belongs to set B and does not belong to set A, so we can say that A is not equals to B, right? Okay. Let's come to the third question. Examine whether the following statements are true or false. The first question says AB is not a subset of BCA. So for the ease of solving these questions, we will consider the first sets to be S1 and the second sets to be S2, right? I will refer to S1 and S2 for solving this question. So if you see in the first question, S1 is A, B and S2 is basically B, C, A. Now all the elements of S1 are also elements of S2. Additionally, S2 has one extra element that is not present in S1. So we can say that S1 is a proper subset of S2. If you look at the definition of proper subset, you will understand this clearly. So the statement says that it's not a proper subset, so it will be false. Let's come to question number 2. It says AE is a proper subset of X such that X is a vowel in the English alphabet. So here set S2 is A, E, I, O, U and S1 is A, E. So S1 has all the elements that are also a part of S2, but S2 has some additional elements, so we can say that this statement is true. A and E is a proper subset of this particular set, right? Then question number 3, 1, 2, 3 is a proper subset of 1, 3, 5. Now this is not true because 2 is an element which belongs to set 1, but 2 does not belongs to set 2. So it cannot be a proper subset, it is false. Question number 4 says A is a proper subset of ABC. This statement is also true. A also belongs to set S2, but S2 has some additional elements. Now question number 5 might be a little interesting. A belongs to ABC. Now here if you see, A is not a particular element, but it is a set. When you put curly braces around an element, it refers to a set. So can you say that the set A is element of set ABC? It is false. Why is it false? Because suppose you consider an interval a to b, then what do you say? You say that all the elements in between a and b are not included, right? But here this is not an interval, this is a set, and this particular set ABC has only 3 elements, which is A, B and C. But here if you see, this is not an element, this is a set. So we will say that A is a proper subset of ABC. It's not an element, but it's a proper subset of ABC. So as an element, it does not belongs to ABC, right? So the true statement would be it does not belongs to ABC. So this particular statement is false. Okay, so this is question number 5. Let's go to question number 6. It says that x such that x is an even natural number less than 6. So write the set first. Even natural number, it should be even natural number less than 6, right? And what is set to? It is all the x elements where x is a natural number which divides 36. So it will be 1, 2, 3, 4, 6, then 9, then 12, then 18, then 36, right? You can check all these numbers divides 36. Now 2 and 4 lies in this particular set as well. So we will say that S1 is a proper subset of S2. This statement is true. I hope this is clear. Okay, let's go to the next question. Prove the statement A union B is equals to A intersection B is false. Now whenever you are trying to prove something to be false, you have to give one counter example. If you can generate one counter example that does not satisfy this particular argument, then only you can say that the statement is false. So let us generate an example. Say A is 1, 2 and take B to be 3, 4, 5. You can take any example. I have taken a random example. So let's find out A union B. What will that be? It is 1, 2, 3, 4, 5. And what will be A intersection B? If you see, A and B has no common elements, right? So it will be 5. Now from this particular example, you can see that A union B is not equals to A intersection B. So we have proved that this statement is false. If you can show one counter example, then it is sufficient, right? Let's do one more question, then I will end this video and we will do the next questions in the next lecture. So this question says, write down all the subsets of the following sets. A. So the first set is given to be A. Now in the properties of subset we have stated that phi is a subset of every set and the set itself is a subset of every set, right? So A has only 2 subsets. Question number 2, AB. Phi A will be there always. What are the other subsets? A will be a subset, B will be another subset and AB will be another subset. So this set has 4 subsets. Question number 3, 1, 2, 3. Phi will be there. 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3. So this particular set has 8 subsets. And 4, phi. As we know, phi is the null element. It represents the empty set, so it does not have any subset, so we will say it is phi only. So the subset of phi is phi itself. So that's it for this video. I will solve a couple of questions in the next video. So let's meet in the next lecture. I hope you find this video helpful. If you do, don't forget to like, comment and subscribe. Thank you.